Hi, Algebra 3-4. This was from page 74 that we didn't get to in class because my iPad wasn't working. So, sorry. But that's okay because this is just reviewing evaluating functions. So I want to write that over here. Evaluate means like you plug in a value. So we're not solving. So you have your input and you find your output. So remember a function machine. Okay, so we are given x equals -2. So I'm going to plug that in wherever I see x. And I'm going to show my function notation when I do that. So I'm going to zoom in for a second. So I'm saying, okay, what is happening for this, like, it's a line, but for this function at -2. And so I would plug this in. I like to show the f part just because I feel like it's more whole. It keeps me organized. Oh dear, what is that, -13? And so what we're allowed to say is this, like this is the outcome. And so what we're going to also be able to write is an ordered pair. So I would practice this as much as possible because it reinforces that this is my x, my input, and this is my y, my output. Okay, let's change colors for the next one. X equals 0.5. Oh dear. Okay, so I have two x's, so I need to like be a little bit mindful of that. So same thing, I'm going to write this f of 0.5 equals 0.5 divided by 0.5 plus 2. I'm going to write it like this because half plus 2 is 2.5. So then I'm like, okay, how many times does 2.5 go into 0.5? Not a whole time at all, in fact. And it is on my calculator. It tells me this. This is like like a flip and multiply type thing, but we're not going to do that. So I get 0.2. So again, I can write this as an ordered pair. 0.5 comma 0.2. So that tells you my x value and my y value. So I could plot that point on a graph if I wanted to, if I had to. Okay, the last one is a radical function. That's okay. We like square roots. This one's nice. It's not bad. So I'm going to plug it in here underneath my radicand. F of 10 equals square root of 10 minus 1, which is the square root of 9, which is 3. And I'm going to leave it as just positive 3. Here's why. What would that be? 10 comma 3. Because on my graph, if I may, and it's been moved to the right one. So what I'm saying here is that, let's call this 10. This is 10 comma 3, right? I don't have, right? This is not an option. So the negative is not part of my function here because it's not a function then. So that's why for this I would only take the positive. If you gave me plus or minus, I wouldn't be too mad about it. But then I would sort of push back and be like, well, what do you mean? Like, show me on the graph where this happens. Tricky. Okay, the prochaine. So that's page 3. This is page 4. Page 4. All about whales, so just go with it. So this page talks about domain and range. And so we want to define that down here in a second. Okay, so this data is real. The number of humpback whales, W, cited in Maui's annual whale census for year X is given by, and then I have these values. So let me see here. What can I do with this? I'm going to do this. I have all these values. Dun, 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 dun. So I have 2005 to 2009. Okay. So evaluate. So part A, evaluate W of 2008 and interpret the result. So it's asking me for this one. Hold on, I need to move that box. Okay. So I know because I don't need to like actually do any math. I have this. So in the year 2008, I had, if I were the keeper of the whales, 1,726. So then I would say like in the year 2008, there were 1,726 whales counted. Yeah, there could have been more. We just didn't see them. Okay, so I have my years. I'm able to tell an output. So again, my input is X, and that is the year. My output, in this case it's W, but it's also Y. And that is the number of whales. That's why it's W. Okay, so for question number 2, I want to highlight this. Identify the domain range of W. Okay, so let's start with the domain first. Can I do this? So domain is X, so I'm going to maybe like put a circle around that. So this is my domain. So in this data, I have a limited amount of data. So my domain is actually the elements as they were. So I'm going to write it like this. And I think some of you are going to be annoyed by this, but that's okay. There is several ways to write this, and we're gonna actually talk about that in class because I got some pushback in your I think it was the find the error. I'm not sure. I can't remember now that I'm talking to you. But I am always hesitant of statements like always or like, oh, you do it this way, because it's not necessarily true. So these are individual elements because this would be like a discrete function. Discrete means it's not continuous, right? So I'm only counting the whales, right, by the year. The other thing that you could do technically is write it like this. I know. So that means that if I'm using years, this is my domain. If I'm using years, I can say 2005 to 2009. I'm including 2005. I'm including 2009. And I'm only counting by years. I'm not counting by months. I'm not counting by half years, leap years, nothing. It's just only years. Okay, so those are two options. So these are both technically correct. So let's talk about the range for a second because the range gets weird. So the range has different values. Maybe you already knew that and you're like, whatever. So I'm going to start with the smallest because that's usually how we do math. 649. Didn't I just say always was like a dangerous thing to say? So what's my second smallest is 2007. 959. And then after that it is 1010. After that it is 1265. Okay, so it's increasing if I mix up the years, right? 1726. 1, 2, 3, 4, 5. Okay, so that is my range. You'll see it, and again, you can write it different ways. You can write it, sometimes people just do a whole curly bracket and like list them out like that. I like to have them be individual because it's discrete. It's a discrete graph. Okay, so I cannot, in good faith, oops, I want to shrink this for a second. I cannot, in good faith, and let me circle this with my pink. This is my range. Say that it goes from 649, right, to 1726. I don't have 650, right? Like I don't have that. I don't have 1725. Nope. It's not continuous. And so here are the elements. So we're going to say elements listed for discrete data. I know, I'm a monster. If I have a nice curvy little graph like we've had, then great. I have those endpoints. I'm able to talk about that. For discrete data, I can't really. Okay. I bet there'll be questions. I bet there'll be questions in real life. And that's why I miss you. Okay, last thing. Describe the pattern in the data. Well, I don't know. It starts low, which makes me sad. It increases. It decreases. And then increases. And then decreases. Okay, so that means to me what? That like the census, the population depends on the year? Depends on the weather, depends on hunting. I don't know what it depends on. So I'm going to say something like the data is varied by year, but ultimately it's increasing, still increasing over time, right? I mean, it is. Hopefully. I wonder what it is now. Oh dear. Okay, the very last thing, I know this is kind of messy. Surprise. You're not surprised. Is this domain and range. So let's finish this up here. So I'm just going to say two things. I'm going to say, well, because it's domain and range. So I'm going to say domain is all possible values of X, which means that they're defined on that domain. I know. The range is all possible values of Y. And this is like for the given function. Okay, that's that. So make sure you have those notes. Feel good. Be happy. Someone tell me how the whale census did last year. Okay, bye.